Welcome to AI Frontiers. Today, we're exploring cutting-edge robotics research as described in 9 papers from June 21, 2025, on arXiv preprint server. This podcast is titled, Robotics Unleashed, AI's Next Frontier. In this presentation, we'll explore the latest advancements in AI-powered robotics, unveiling key research themes and breakthrough findings. We aim to demystify complex concepts for a broad audience, highlighting real-world applications and future directions, with a special focus on how humans and robots interact. Robotics is a symphony of disciplines, an interdisciplinary field encompassing computer science, mechanical, and electrical engineering. Its goal is to design, build, and apply robots to solve real-world problems. Robotics automates tasks, assists humans, and explores dangerous environments. It relies heavily on AI for perception, decision-making, and learning. Computer science provides the core intelligence for robots. One key research theme is learning-based control, where robots learn from experience instead of explicit programming. Machine learning techniques like reinforcement learning and imitation learning are crucial. Kunapuli et al. 2025 specifically explores reinforcement learning for quadrotors. This approach allows robots to adapt to new situations using trial and error, with the ultimate goal of teaching robots to fly better than they can be programmed. Another vital research theme is sim-to-real transfer, focused on bridging the gap between simulated and real-world environments. Training in simulation is safer and faster, but often fails in reality due to the complexities of the real world. Techniques like domain randomization and system identification enhance transferability. Chang et al. 2025 addresses sim-to-real challenges specifically for autonomous underwater vehicle docking, simulating the real ocean environment for robots. Vision-language action models are another major area, enabling robots to understand and respond to human instructions. These models combine computer vision, natural language processing, and robotics, allowing robots to execute tasks based on verbal commands and visual input. Chen et al. 2025 is working on compressing these models for real-world use, while Kwok et al. 2025 focuses on making these models more robust to environmental variations. Key findings from the analyzed research papers include Kwok et al. 2025's RoboMonkey improving vision-language action robustness by 25%. Chang et al. 2025 making progress in mitigating the sim-to-real gap for underwater docking. Kunapuli et al. 2025's rigorous benchmarking challenging previous reinforcement learning superiority claims. Kian et al. 2025 showing that embodied robots enhance engagement and therapy. Finally, Farhat et al. 2025 improves the reliability and safety of robots when grasping objects. Common methodologies include reinforcement learning, where robots learn through trial and error. Imitation learning, where robots learn by observing human demonstrators. Sim-to-real techniques, aimed at bridging the simulation-reality gap. Vision-language models, enabling understanding and responding to instructions, and experimental validation, used to test algorithms in real-world scenarios. One selected research paper is RoboMonkey, Scaling Test Time Sampling and Verification for Vision-Language Action Models by Kwok et al. 2025. Its objective is to improve vision-language action robustness in unstructured environments. The RoboMonkey framework leverages sampling and verification. The findings demonstrate a 25% improvement on out-of-distribution tasks. This is a practical method for enhancing vision-language action performance without retraining, allowing the robot to reason about the scene and choose the best action. Another selected research paper is Leveling the Playing Field, carefully comparing classical and learned controllers for quadrotor tracking by Kunapuli et al. 2025. The objective is to fairly compare reinforcement learning and geometric controllers. The method involves addressing asymmetries in task definition and data access. The findings show that performance gaps are smaller than previously reported, highlighting the importance of rigorous benchmarking. Geometric controllers are better for slower tasks, while reinforcement learning excels when greater agility is required. The third selected research paper is Engagement and Disclosures in LLM-Powered Cognitive Behavioral Therapy Exercises A factorial design comparing the influence of a robot versus chatbot over time, by Kian et al., 2025. The objective is to assess the impact of embodiment on engagement and disclosures. The method uses a factorial design comparing robot versus chatbot over 2 weeks. The findings show that the robot condition demonstrated increased engagement over time, suggesting embodiment plays a crucial role in therapeutic technologies and the robot's physical presence enhances trust. Future directions in robotics include bridging the sim-to-real gap, developing robots for unstructured and dynamic environments, and ensuring the safety and trustworthiness of autonomous robots. There's a continued focus on robust learning algorithms and creating human-like robots. The ethical implications of robotics also need further discussion. This podcast was written by AI using models including Gemini 2.0 Flash, TTS synthesis by Google and image generation by OpenAI. The content was reviewed by a human expert. There may be potential oversights. All references are provided. Thank you for listening to AI Frontiers. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Subscribe to AI Frontiers on YouTube to stay up to date with the latest AI research and join our community of AI enthusiasts. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.